Hello everyone. In this video, we are going to determine the inverse of square root function by adding a restriction, and this is the second part. Let's take this example right here. Determine the inverse of the function f of x is equal to negative square root of x minus 2. I have here a piece of paper to show how we can sketch the graph for this to better see how the graph of this function look like. So I'm just gonna write that up here. So I added the k value for this equation that we have right here so that looking at this, we can go ahead and say that our h is this value and this is our k, so that our vertex is actually located at 2, 0. So I'm just gonna write that up here. Okay, so we are going to determine the equation so that we can fill the table. So I'm just gonna write that down here. Okay, again, the trick in order that we can determine the equation to use to complete the table is to cover the value of the h and we cover the value of the k, and whatever's the left over, that's the equation that we're going to use. So that we go ahead and left with y is equal to negative square root of x. So this is the equation that we're going to use in order that we can complete the table. So from the vertex, okay, we are going to fill this value 1 and 2 to the x here so that we can complete this blank parts of the table. So I'm just going to show the work on the side here. So that would be negative square root of the number that we put again would be 1. So I put 1 right there. So negative square root of 1 is negative 1. So I write negative 1 here. Since that's a negative, it means that we are going down. And so we do the same thing for the next one here. We have 2. So I put negative square root of parentheses, and then we put in the 2 there. So that square root of 2 is actually 1.4 and there's a negative in front, so that's negative 1.4, which means that we are going down. So that from here we can go ahead and sketch the graph of this function f of x is equal to negative square root of x minus 2. So we start from the vertex 2, 0. So that would be 2, 0 right here. So that's the x and the y. So that's 2, 0 goes here. And then we go ahead and say that from the vertex, from this point right here, we go 1 right and 1 down. So I go 1 right and 1 down. So this is where it's going to sit. And then we go ahead and say from the vertex, we go 2 right and negative 1.4 or 1.4 down. So from the vertex, 1, 2, negative 1.4, which means it's down. So 1 and 1.4 is approximately somewhere around here so that we can connect these dots together to create the graph of the given function, which is negative square root of x minus 2. So that looking at this graph right here, we can tell that the domain for this graph or domain for this function that we have here would be x is greater than or equal to 2, because that's where it starts from. And then we go ahead and say that the range for this is anything lower than 0. So that would be y is less than or equal to 0. So that we can go ahead and change the color for this given function that we have here. I'm going to use red for that. So I'll change this to red. So this is the graph of our function negative square root of x minus 2. Now we are going to determine the inverse of this function right here. So I'm just going to show the work on this part right here. So what are we going to do is we have some steps to follow in order that we can determine the inverse function for this. The first step is to replace f of x with y. So in this equation, this will come out y is equal to, it's going to be negative square root of x minus 2. So that's the first step. The second step is to replace every x with y and replace every y with x and solve for y. So this y will become an x, and that is equal to the negative square root of this x becomes a y minus 2. part of this step is to isolate y by itself, but there's a negative in front of this. So what are we going to do is we will divide this both sides by a -1. So if we divide that by a -1, we can cross the negative and the -1 right there. So we are left with x divided by -1 is -x. So I'm just going to write that down here. So that's -x is equal to the square root of y minus 2. Again, we are supposed to solve y by itself here, so that we are going to get rid of the square root here. In order that we can do that, we are going to square both sides. So I'm going to square this side. I'm going to square this side as well, so that we can cross the square root and the squared out. Now, we remember that if we have two negatives multiplied together, because this -x squared means -x times -x. That means this is just an x, so I can just go ahead and write x is equal to, we already have gotten rid of the square root, so that would be y minus 2. Again, we want to solve for y by itself, so we're going to add 2 to both sides. So plus 2 and then plus 2 here. By the way, this is supposed to be squared because that is -x and -x. So that we can go ahead and cross out the -2 and the 2 here. So we are left with x squared plus 2 is equal to y. So that we go ahead and move on to the third step. The third step is to replace the y of the equation solved in step 2 with f-1 of x. So this would come out f-1 of x is equal to, again, the y was changed to f-1 of x. So I'm just going to write this one on the right side here. That's x squared plus 2. Now, we are going to sketch the graph of this inverse right here and determine how can we restrict it. So I'm just gonna show the work on the other piece of paper that we have right here. Okay, so we can actually change this to its graphing form. We only have a k value for this. We can rewrite this as y is equal to, that's x plus 0 squared plus 2, because others are going to think that there's no value for h because it's not there, but that's a 0 right there. So we can go ahead and say that our vertex is actually located at 0, positive 2. So I'm going to write that down here. Okay, so then we determine the equation that we need to use in order that we can complete the table. So I'm just going to write that down here. Okay, again, the trick in order that we can determine the equation that we're going to use to complete the table is to cover the h value and to cover the k value at the same time, and whatever is the left over, that would be the equation that we're going to use in order that we can complete the table. So that would be y is actually equal to, that's x squared. So then from the vertex, okay, we are going to use this equation that we have right here. The x value are the ones that we have here, so we plug it in. So that would be 1 squared. So I put the 1 right there. So again, the 1 comes from here. So that's 1. So 1 squared is just 1. So I go ahead and say that's 1 here. Since it's positive, we go up. And then we determine the value for the other cell right here. So that would be 2. So then we square it. So 2 squared is 4. And so since this is a positive 4, so we go up. So then we can sketch the graph of the inverse function that we have here, which is f-1 of x is equal to x squared plus 2. So we start from the vertex 0, 2. So the vertex is right here, 0, 2. And then it says that from the vertex, we go 1 right and then 1 up. So 1 right, 1 up. So it's going to be right here. And then we also have 2 right and 4 up. So 1, 2, 1, 2, 3, 4. So it's going to go this way. Since this is a quadratic equation, the shape of the graph is a parabola. So I'm going to reflect it across on the other side. So this would be the shape of our graph right here. So I'm going to draw both branch of this parabola right here. Now, looking at this, we can tell that they don't actually match up if we fold it across the line of symmetry y is equal to x, so that we are going to pick only one of these two branches, so that we are going to be able to have it reflected on this given function that we have here. Just by looking at this, we can actually tell that this left branch is the one that would match up if we fold it on y is equal to x. So that means that we can actually erase this other branch that we have here. Okay, so we actually have to restrict it. From our restriction that we have here would be our x should be less than or equal to 0. So anything that is less than 0, and so we can go ahead and say that our domain for this given inverse graph that we have here is x is less than or equal to 0, and our range here is y is greater than or equal to 2. So that's the domain and the range there, so that we can go ahead and change the color for this inverse graph here. I'm going to use blue for it. So this is the shape of the inverse graph. So pretty much this is our f of x, and this is our f of -1 of x. As you can see here, these two graphs are actually symmetric with respect to the line of symmetry, which is y is equal to x. So I'm just going to draw that line of symmetry up here. Okay, you can see that if we fold this graph across the line of symmetry, y is equal to x, these two will match up. So again, we had to restrict it. That means we had to take the other branch of the parabola, because it's not going to match up. There's no other branch across from it. So that we can go ahead and say that our restriction here should be x is less than or equal to 0. So this is our inverse for this given function right here. Now again, notice that we use less than here, because again, the trick is if that's a negative, we use less than. So I use x is less than 0, so that these two graphs will match up if you fold it across the line y is equal to x. Again, we need to restrict it so that both of them will match up. If you don't restrict it, then you still have the other branch here, and there's no partner across when we fold it. So then it's not really the function, because it doesn't really look like the reflection of the other graph. That's it. If you find this video helpful, hit like and subscribe for more math videos. See ya!